Hello, everyone. My name is Shockley. I am a robotic engineer in D-Robotics. And today I'm very happy to share about this topic, measurable in action, from multimodal perception to robot interaction. And today I will discuss, and I will focus on one practical question. How do we turn the AI model output and into the real robot behavior on RDK X5? And I think most of you have already entered the stage 2 in our RDK challenges. And in stage 2, you need to write a proposal about your project. And in this proposal, you need to know what algorithm you need and what the actuator you need. So in today webinar topics, I think it's very helpful for you to know how to write this proposal because I will take our Magicbox, these little guys, as an example. So what's Magicbox? Magicbox basically is a platform that made this question visible. We connect a camera input, microphone, and model influence, and use two topics, servo and LED, and a speaker output into a little box. And today I will show you four practical demo. So let me have a quick look about what is Matchbox to help you have a deeper understand about this little guy. And also there is also a developer documentation in here. If you want to reproduce our demo later after the webinar, you can follow this link. So let's have a quick
Learning
look of
robotics development.
this video.
Still piecing together various modules. Complex wiring, debugging is exhausting. The more you fight, the more you collapse. Building from scratch wastes too much time. Now, one device solves all your problems. RDK X5 Magicbox Multimodal Intelligent Robot Development Platform. Highly integrated, bid farewell to cumbersome assembly. Stereo vision. Voice interaction. Lighting effects. Dynamic rocker arm. 10 tops computing power, ready to use out of the box. Unbox and witness AI power immediately. No complex configuration needed. Rich examples run them directly. Results instantly visible. Supports OpenClaw development. Quickly build your AI agent. Robot experience. Teaching, development. All in one. D-Robotics, your robotics dream keeper.
So as the video mentioned, Matchbox show the full loop from sensing to the robot response because Matchbox can have can receive your inputs, including the stereo camera and microphone, and you can convert this message for your topic, and you can influence the data using our BPU, and it can generate some output that the actuator can like the servo and LED can use our model feedback. So let me have a quick notes about about the RDK about the Magicbox. So as you can see, this in the Magicbox we have an RDK X5 and RDK X5 run the use tool, and RDK X5 also have BPU and CPU which can influence AI model. And in the other side, the Magicbox has a speaker, stereo camera, and IMU, which communicate with our RDK X5 via I2S. And our Magicbox also have a MIPI camera, which can detect the depth. And also we have three buttons in our RDK in our Magicbox, and using our GPIO to control this button. And also we also have a LED we also have LED to help developer load the Magicbox statues, and RDK X5 can control this LED via SPI. And we also have Ethernet, which is very convenient for developer to connect our Magicbox for debugging. So today I will show you 4 demo about the Magicbox. And the first demo is the measure the distance. In this demo, we can use a stereo camera to detect the depth of the obstacle. And the second demo is control the Magicbox servo via our hand, so that we can control our Magicbox using our gesture. And the third demo is a chatbot demo. In this chatbot demo, we run a local LLM model, ASR model, and TTS model, so that the Magicbox can understand our word and respond. And the demo 4 is also a chatbot, but the LLM model and ASR TTS model running in the cloud, so it's very smarter than the demo 3. And in the demo 1 is the stereo depth demo. It turns two camera view into subscribable depth. The principle is stereo matching. The left and right camera observe the same scenery from different positions, and the same physical point appears shifted between the two images. And for developer, the important output is not only a color visualization, which will publish a depth map, as you can see, and also a point cloud topic. So you can subscribe it in those tools to do some robotic application like navigation and the localization in local motion. So let's dive into the technical side. Let's learn about how the depth demo run. So first, the VP stereo camera provide left and right images. Second, the system combine them into one image topic. And then stereo rectification align the two view using calibration. So, and replication is very important because corresponding points should lie on the same horizon skyline. And the last one is AI model inference. This stereo V2.4 model run on the BPU, and it can estimate disparity. Finally, post-processing convert the model output into depth visualization and point count. So developer can get these 3 topics for use. For example, you can use the depth image topic to detect the distance and avoid the obstacle about your project. And the second topic is a visual topic. We can see the camera video feedback via our web, so that we can have a quick look about what the camera is capture. And the third one is point cloud. You can use point cloud to have a visual localization or the visual navigation. If you build a car project, for example, you can use this example to help your car localization in your room or avoid the obstacle. And let's have a quick look about the code about this project. So as you can see, I have entered our Yoast workspace, and in our Yoast workspace, we have a lot of packages, And the hobo stereo net is today's demo. We can find the instruction about how to launch this program easily in our documentation. We can run this command to launch our demo easily. For example, the first thing is enter our workspace, and the second thing is type this command. So as you can see, it's launched successfully, and now we can open our Chrome and enter this IP address so that we can have a visualization about the theft detection. So as you can see, it can detect the theft. So it's very so let's move into the last part. So if we have this theft information, so what can we do? Here is a demo which done by our D-Robotics colleges. So let's have a look.
Hi everyone. In today's demo, I've built a real-time system that tracks hand distance and turns it into emotions of a virtual character using RDK X5. For more information, please check the link below and join our Discord channel. The demo uses the RDK X5 as the core processor that has 10 TOPS AI computing power connected to a GS132 binocular camera. It runs both stereo distance estimation and human detection models simultaneously on the RDK X5's NPU. As your hand moves closer or farther away, the character instantly changes its behavior, from panic when you get too close to calm and happiness when you move away. This creates a simple but intuitive form of human-like interaction based purely on spatial awareness. The screen also shows your hand's current depth estimation. The accuracy of it is within 5% under the hood. This is powered by the RDK X5 NPU, which runs multiple AI models simultaneously by combining stereo depth estimation with human detection and fusing their outputs. The system can precisely measure the distance between your hand and the stereo cameras in real time. The entire pipeline runs live on a program by launching multiple ROS2 nodes with a lightweight web interface for visualization, demonstrating how Edge AI can turn raw perception data into expressive interactive experiences. As always, you'll find links to the technical blog and our Discord. How Edge AI can turn.
So as you can see, this demo actually run two AI model. The first one is I just mentioned is an AI theft detection model, and the second one is the gesture detection. I will introduce this demo in the last part. So the last part is control our Magicbox by our gesture. So in this demo, we run a lot of gesture detection model, and finally we turn this model output to our actuator control, like the servo movement and the LED behavior. So let's dive into the pipeline. So the visual pipeline begins with a MIPI stream. The system detects the body or hand region, estimate 21 hand landmark, and then it output a gesture detection. And after we have some filter to fit this gesture detection result, and then we turn this result and mapping into the servo or LED movement. So this slide illustrates why gesture control system is very easy to modify. So because we use a ROS tool to help us write different function into different packages. Like we have a iterative function, we have iterative packages to help us control the servos, and WS2A, 1 to B is actually a LED light. And we have a AI influence node to help us influence the gesture detection AI model. And also we have a function call topic, which means the AI input can call this function, and then we can move our servos. And as you can see, we have mapped this gesture to our robot movement. For example, if we form up, Matchbox can raise his arm positively, and let's have a so let's run this demo together to see what it actually moves. So as I mentioned before, we can also find the instruction or our documentation. We can launch this demo easily, just one command. So as you can see the detection result via our website. So if we do if I do a thumb up, it can move his arm, and from left, it can move one arm, and from right, it can move another arm. And if okay, this is the gesture control demo. So the gesture control demo package is over there. So as you can see, I have launched this Python script to launch the gesture control demo. But basically, it have launched a multiple detection algorithm. So the first demo is our checkbox. So this checkbox is run locally in our RDK X5. So all the model is, which means all the model is run locally. For example, the KWS VAD model help our RDK X5 to detect the speech, which sound turn it into the AXR detection, and the AXR help us turn the speech into the text, and our prompt text turn into TTS, turn into the large language model, and the large language model generate the output to the TTS, and the TTS transform the text into the sounds, and then play this sound via the audio. So let's have a video to see how it works.
Who are you?
Smart Assistant created by D-Robotics.
So let me have a look about what happened after the wake walk. So the wake walk actually is the hello. This is the wake walk. And after the system listen about this walk, and the VAD decide when speech start and end. The ISR convert the sound into the text, and the recognition text is published to the prompt text. And the local print LLM 1.5 model generates a reply, and the reply is published as TTS text. And the TTX text turn into our TTX audio for the speaker playback. During the playback, the microphone is paused and controlled, so the robot doesn't recognize its own sound output as a new command. So this topic level, so this is so we use our roles to visualization about the processes about the ISR generated text and the large language model output text, so we can debug easily. So as you can see, this slide shows which local model we use in this demo. For the KWS and VAD model, and the TTS model, and the ASR model, and the TTS model, all from the Sherpa Onyx family. And the ASR model we use Sense Voice is a very common model for transform the voice into text. It also supports English, Chinese, and other languages. But if you run in the local, you must select some small model to run in the RDK X5 because the memory is limited. So as you can see, this workflow. So when you listen to our way upward, the LED will away to. So we have designed a same machine to help our user to recognize which stage the measurable is. So the one machine is wait for the LLM, and the second is thinking. Thinking means the matchbox inferring the large language model to the output, and the third stage machine is TTS playback. So in this stage, the microphone will not accept any voice because the audio is speaking, and all these machine states will have different LED states, so user can understand which state it is. So this slide show those two topics. For example, it published a prompt text, which means the ASR detection, and the ASR and the TTS node subscribe the TTS text to playback its sound. And you also have a service. It is audio statue. It can make the large language model node to know which state the audio is. And this to find is our program to run LED to run LED and audio hardware, and this find is to inform our ASI and VAD KWS model pipeline. So let's also have a quick look about how to run this demo. So to run this demo, the first one is to launch our local clean LLM load. And the second command is to run our audio node. So now after I run this two command, I can
Hello, how can
talk
I
with
help
it.
you?
Hello, please introduce yourself.
Robotics focuses on building the essential infrastructure for robot intelligence, aiding in the development and scaling of smarter, more intuitive robot capabilities.
Hello, who are you?
Hello,
Hello, who are you?
I am D-Robotics, a company dedicated to creating foundational infrastructure for robot intelligence. My goal is to help robots develop and scale for smarter, better everyday experiences.
So as you can see, you can detect what I say, and after detect what I say, it put this prompt to our Queen model. Our Queen LLM model will generate the result and then turn it into a TTS node, and the TTS will play this voice to our audience. So, but this demo look a little stupid, right? Because it's run locally. So in the next demo, I will show you how can we run the cloud model in our chatbot in our Magicbox. In this demo, I will show you run a cloud model, which is Mimo. Mimo is a large language model provided by Xiaomi, and the TTS and ASR also Mimo. And the local in the local path, the RDK the Magicbox provide the servo movement and the LED control function to let our large language model to send some MCP servos to MCP control command to control the servo movement and the LED light. So this workflow is similar to I just mentioned. It's similar to the local chatbot. The first one is VID and ASR model to detect the sound, and the ASR model will turn the switch into the text, and then the text will put into the Mimo LLM model, and it will call the API function to transmit this prompt to the cloud and wait for the cloud feedback, and then it will also put this feedback to Mimo TTS model. And finally, it will turn this audio to the speaker. So let's also have a quick look about this demo. So it's very easy to launch this demo. We just use one command. So as you can see, it's launched successfully, and it start detection now. So because Mimo is a multi-modality large language model function, so you can receive the image input. So in this demo, I also launched our camera because, as I mentioned, Mimo is a multi-modality model, so it can receive the image input. So if I ask,
Option. Could you please clarify or
Hi-
let me know what you'd like me to help you with?
What can you see now? Hello, what can you see?
I can see a room that looks like an office or meeting space. Here's what's visible. A whiteboard on the left side, mounted on a stand. A black office chair in the foreground. Glass walls partitions in the background. Ceiling lights that are turned on. White walls with what appears to be a light switch on the right side. The view is from a lower angle, looking upward. Is there anything specific you'd like me to look at or help with?
Hello, please introduce yourself.
Oh, I'm Magicbox, a physical robot assistant created by D-Robotics. I have a body width, weft of my feature, still passing out hope, then I can raise or lower. Stereo concepts at the empty several full stop still at me, asking the once we are flobbing as my magic modulators just bite blastedly until we consider. Mix. For something looking like a US EU launch flyer. Keep it in third venomant claws
Hello,
because it's
can you move your arm?
for endless life. I'm here to help you with various tasks.
Oh, it looks like you have a many words to speak. So let me restart again. And it has another function because Mimo is quite smarter than the local model, so it can control its arm or it can control its light.
Whatever you need. Could you please clarify what you'd like me to do?
Can you
Whether it's moving my arms, changing the lights,
change your light?
conversation. I'm here to
Hello,
assist.
can you change your light? Can you change your light? Oh,
I'll
as
change
you
my
can see, it changes its light to breathing effect.
gentle breathing effect. Would you like a different color or pattern?
So actually, this is a VLM model with MCP control function. It can not only receive our voice, it can also receive the camera feedback. For example, it can see the surrounding, so it can understand where it is. And also it can control its arm and also control its light to express its emotion. So it's very interesting and funny demo. So this is the end of today's webinar sharing.